So this is a basic diagram of an op amp, an operational amplifier. We have the two inputs, a positive input and a negative input. We call the positive input non-inverting and the negative input inverting, a resistance between them, because to represent the power loss that's going to be happening within the amplifier. And then within it, we also, to show that power is not coming from nowhere, we're going to say there'll be some voltage source producing the power is going to come out. And since we're not in an ideal scenario here, there will be some resistance drop, although we hope it to be like nothing. And then the output will come out to here. So how do we use this? How do we use this op amp to produce amplifications that we need? I'm gonna most likely answer that question in the next videos. But for now, what I would like to do is just explain some of the rules of the op amps and ways of using them. So to begin with, this is a differential amplifier. So usually an amplifier would be like one input, one output, it gains it by a certain amount. But a differential amplifier looks at these two inputs, then multiplies the difference between the two. Multiplies the difference between the two. So I hope that makes sense. And so when we close loop this amplifier, when we provide a feedback, let's say we rewire this place to here, or rewire this place to here. In other words, the output has some wire connection to the input, some amount. Even if the resistance is really high, as long as it has some amount of connection, we're gonna have two key points, two key rules that you must follow if you want to really simplify the circuit in a nice way. Otherwise, you can go mathematically and solve it. But these are two rules. If you know them, you can simply take the shortcut and solve any feedback op amp. And so the ideal op amp would have no current going into its input. And that's simple, because we do not want any power loss happening over here. So we just wanted to read the voltage and then then find the difference of that. And then that's it. So rule one should be easy to understand. And then the second rule would be the voltage at the positive and negative input must be the same. The op amp wants to make these two voltage inputs the same. But it can't do that now because it's not connected. So it's just going to multiply the difference. And because an op amp typically has an amplification of 1 million and sometimes up to 1 billion, then we really either want really small differences, like 0.00000 difference. Otherwise, the op amp will come into saturation and there's no point of amplification. So how do we control our amplification? Well, the point is, if we feedback it and use these two rules to solve it, then we can come up with an amplification that perfectly suits our input needs. And so here's an example. We have a voltage source and we want to amplify it a certain amount. Well, we can connect the voltage source to the positive, to non-inverting input, the positive input, ground the non-inverting, the inverting input, and have a loop back. And in the next video, I will show you how you solve these kind of problems to see what kind of gain will happen with respect to the resistance here, and in most cases another resistance here. And so this should help you understand how you can use the differential amplifier that was, in a sense, by the name, it implies that it takes a difference between two inputs, but use that to your advantage to just simply amplify the voltage you get in. So, hope that helps.